Dear students, the next problem from class 11 work energy power chapter, example 6.6. See the question. A block of mass 1 kilogram moving on a horizontal surface with a speed vi, that is initial velocity, 2 meter per second, enters a rough patch ranging from x is equal to 0.1 meter to x equal to 2.01 meter. The retarding force Fr on the block in the range is inversely proportional to x over this range. So F of R, the frictional force value is given as minus k divided by x. See that here inversely proportional. So this force acting the range from 0.1 meter to 2.01 meter. That means 0.1 to 2.01 meter only the frictional force is present. Okay. Before the 0.1 meter or after 2.01 meter, no frictional force. That means 0. So 0 for x is less than 0.1 meter and x is greater than 2.01 meter. That is the meaning. Then where k is equal to 0.5 joule. What is the final kinetic energy and speed Vf, that is final velocity of the block as it closes this patch. Okay, so first with the help of the diagram we analyze the question, then we are going to solve this problem. Let's see now. So in this question, a block of mass, so it's a block, the block of mass m is given, that is 1 kilogram. Okay, so let's imagine it is travel in the one dimensional direction. Okay, so let's we consider its initial velocity is given as, that is vi equal to 2 meter per second. This is initial velocity. So in this path, let us imagine this position is x is equal to 0.1 meter. Then let's imagine this position x is equal to 2.01 meter. Here the friction value is available in between 0.1 to 2.01. So this only the frictional force available range, that is Fr is equal to minus k divided by x. This only given in the question with the limit of 0.1 to 2.01 meter. Then less than 0.1 this side. So here less than 0.1 there is no frictional force, that is Fr value is equal to 0. Then greater than 2.01 also this side, greater than 0.1, so this side also the frictional force value is 0. So friction is available in between this gap. So here before entering 0.1 meter, its initial velocity is 2 meter per second. While travel from 0.1 to 2.01 meter, what is its kinetic energy and what is its kinetic energy, that is a final kinetic energy, then what is its final velocity. So these two value only we are going to calculate in this question. So now let's see the solution for this question. This is from by using the work energy theorem. So we know very well that is a work energy theorem, that is W is equal to final kinetic energy minus initial kinetic energy. So this change in kinetic energy only we called as work done, that is work energy theorem. But now in this question we are going to calculate final kinetic energy, that is a Kf. So K is moving left side, so initial kinetic energy plus work done. So we can write as Kf is equal to Ki initial kinetic energy, that is half mvi squared, then plus work done. So that work done we can write by using the variable force idea, limit from x1 to x2, then force into that displacement concept. So now we can write Kf is equal to half into m into vi squared plus x1, that is the initial position. So in this question initial position you know that is 0.1, final position 2.01. Actually this is x1, this is x2, that is a limit. So now I can write instead of x1 that is 0.1, instead of x2 that is 2.01. Then what about the F? That means F is the frictional force, that is Fr. Fr value given as in between the limit is, that is minus K divided by X. So that I am going to write here minus K divided by X, then into dx. Now next step, Kf is equal to 1 by 2 m value, that is a mass is 1 kilogram, then velocity, initial velocity 2 meter per second, so 2 square. So next step, Kf is equal to 2, here 4, so if we cancel we can get only the 2, okay, only the 2, it is a 2. Then after that this integration part, let's come for the integration part. I'll take minus K is outside, so it's become minus K, then integral 0.1 to 2.01 1 by x into dx. Okay, therefore Kf is equal to 2 minus K. So I can write one more time the steps, K into limit 0.1 to 2.01, then 1 by x into dx. Okay, so next step, Kf is equal to 2 minus K value given as, that is 0.5 joule, that is I can write as, that is 1 by 2, then integral 1 by x, integral of 1 by x into dx I can write as, that is log x, that means here log base 10, that is a meaning, that is a log x. So I can write this is log x, then the limit value 0.1 to 2.01. So now we know the one more formula, that is log of, that means log A minus log B is equal to log of A by B. Here also base 10 is the base 10. Okay, so according to this formula we can write the steps, upper limit minus lower limit, that only. So kf is equal to 2 minus 1 by 2. We can write log of 2.01 minus log of 0.1. Therefore kf is equal to 2 minus 1 by 2. Log A minus log B we can write as log of A by B. So log of 10 basis A by B, that is 2.01 divided by 0.1. Okay, so then here 2.01 divided by 0.1, 2.01 divided by 0.1, so multiple and divide by 100. So I can get, this is 201, this is 10, so 201 divided by 10, that is equal to 20.1. That is equal to 20.1. So I can write as kf is equal to 2 minus 1 by 2 log of 20.1. Okay, then we know very well from 0.1 to then 2.01 up to that limit, here exponential variation konjama change agudhu. It's not sudden change. By applying the frictional force it get minus sign, so exponentially changes. But here we can write log 10. This is a normal one. அப்ப நம்ம என்ன பண்ணலாம்னா we are going to change into exponential function. How to write the exponential function? Exponential function எப்படி எழுதலாம்னா log e power x ன்னு எழுதலாம். This is exponential function. Log exponential function நால் ஒன்று தான், or natural logarithm, that is lnx நால் ஒன்று தான். So both will be the same meaning. Okay, but we wrote or we found log 10 base x only we found, but this question is related with the exponential function. But so how to change from log base 10 to log exponential function of x? இது எப்படி மாத்துறது அப்படினா, we want to multiply with 2.303 and log 10 base x. Okay, so now I can write kf is equal to 2 minus 1 by 2. So now we found log 10 base value, we want to convert it into log exponential value, so we want to multiply with 2.303. Okay, so now first we found this value, log base 10 value. So log 20.1, that is equal to 1.303. This value is equal to 1.303. So this value multiple with 2.303. So that is approximately is equal to 3 will come. So this 3 only is equal to log exponential power x. So this log base 10 we can convert it into log e power x. So this is log base 10, we can write as log e power x. After the steps I can write log e power x, that is equal to 3. So please, log base 10 is converted into log e power x, we can get 3. So now kf is equal to 3 minus 1 by 2 into 3, that is 1.5. this is 2. So 2 minus 1.5, that is equal to 0.5 joule. This is final kinetic energy. Because it is a frictional parts, so its kinetic energy is reduced from 2 to 0.5. Then the same question they ask, what is the final velocity? So we know that kf is equal to half m vf squared, final velocity. So this final velocity we are going to calculate. So that is also very simple. So kf, that is 0.5. 0.5 means that is 1 by 2. Again here 1 by 2, mass value 1, then vf squared. 2 will be cancelled. So the remaining 1 only is there. Therefore vf squared is equal to 1. Therefore vf also root 1, that is equal to 1. So 1 meter per second. Okay students, I hope you understood this topic. Here we found the final kinetic energy and then final velocity. So should be careful with the natural logarithm n, or otherwise e power x. So that value is equal to 2.303 into log 10 base x. Thank you.